Next thing is that we're going to see about the function scoping, how the function will be called. Okay, who's going to take the higher reference? Those are the things that we're going to see. Okay, so as we told, right, we're going to discuss about the scoping. Look at this. So variable is equal to 10 function, a simple function, right? So always keep it simple whenever you try to learn. Now I'm trying to print this variable. So I'm trying to do the calling. So what happens if I run? Output will be 10. Why? Because when I call line number 38 will get executed, it will go to line number 34 and it will get reach line number 136. When it reaches 136, it is about to print variable. But inside a function, there is no such variable. So what it will do? Obviously, it will go out and see if there is any variable with the same name. If that is exists, then it is going to print. It is like, inside my, class. For example, if I'm sitting inside a class and if I ask somebody to get me the marker, so what they will do, usually they'll check the marker within our class. And if the marker is not available in our class, that is where they'll go out and get the marker. Correct, that's what it is. Now, it works as expected, correct? Now look at this. Now what happened? Variable. I'm having a variable inside my function itself. Now when I run, look at this. It prints the function, data which is there within my function. That's what, right? If the marker is available within my class, that there is no need or no necessity that I have to travel outside the class to get the marker. Straightforward. So this is what we call it as local scope. The one which I showed on the above example is called global scope. Okay, now look at this. Now what happened? In my function definition itself, I'm trying to pass one argument. So look at this. 1000. This is what you should, keep in mind. You have to see this kind of different scenario so that you will understand how the core logic works inside a function. Now what happened? Basically, I'm trying to have another argument that is also variable. I'm passing 1000. So when I run, very obviously 100. Be careful, guys. It will always give the preference to the the local variable first. For example, I'm asking marker to some of my student. Okay, he says that sir, marker is there inside our class. He'll be taking and give it to me. Sometimes the marker might be personally owned by one of my students, but I won't get that because my marker is already available. If my marker is available, then what is the need for me to get from the student? That's what happening here. Even though 1000 has been passed on to the function definition, it will still consider the one which is inside a local. So always preference will be local. Okay. Now, let me take this one out. Now what happened? This scenario, this is again a different scenario. Okay. So what happening here is that I'm trying to print a variable. Now there is no local variable. There are two variables. One, which is the one I'm calling, we call it as built-in data. I'm trying to pass the data and which is outside a global variable. There you see. It gives preference to the 1000, not on the global. So this is what we call it as enclosed one. Okay, first it will be given to the local, and if something is getting passed on to the function, it will give the preference to that only. So we call it as built-in one. This is what we call it as built-in data reference. And if both are not there, only that we see in first option. It will give priority to the global variable. So the scoping is coming in this way. Local, enclosed, and global. And there is something called B. B means built-in. The focus should be on local, enclosed, and global. That just now we seen three things, right? Local data, and enclosed data, and global data. So all these three we seen it. If you want to keep all these three in a single function, I can do that for you people. Function variable is equal to 100. Definition. There is another function. That another function contains 10. Print of variable new function call. And outside the variable, I'm having something like 1000. When I run this specific code, output will be 10. Because what would have happened? Line number 172 gets called, it will go to line number 161. It will read variable is equal to 100. So initially it was 1000. Now it becomes 100. When it goes into this, it will be calling new function. This is called function inside a function. Okay. But two different functions. Be careful. So it will go to new, and now the variable becomes 10. So it was 1000, and then it was 100, then it was 10 now. So when I print directly, just now we discussed. What is the preference will be local reference. So 10 will be getting printed. If I don't have the local data, what happened? This is the global, because it is away from the function. This is away from this function, but this variable is inside another function. So this is what we call it as enclosed variable. It is not a global, because still it is inside some other function. So now preference will be to the enclosed variable. Look at this, output is 100. Now 100. Okay. Now if you don't have the enclosed variable, that is where it will finally give the preference to the above 1000. Okay. If you, now you got it, difference between the local, global, and enclosed. Okay. So be careful. So whenever you do the operation, you need to be very careful in handling this kind of a scope data. Okay. Now I'm going to take you to another scenario. Now whatever you tried is just accessing a data. Okay. Now let me do this. Def function variable is equal to variable plus 10. Print of where function. So what I'm doing, I'm just calling the function as like most of the time, and I have another variable 100. Okay. So now let me print before the function calling. Let me print the variable after the function call. If it is nothing like the previous case, look at this previous case, right? So there are three print statements. The one which is before the function, one which is after the function, and what which is inside a function. So when I run 100, 10, and 100, first it will be printed. Line number 180. What was that? It is away from the function. If it is away from the function, what is the variable data? 100. So 100 got printed. Now line number 181. What happening? We are trying to do the calling. It will go to line number 175, the definition. It will come down to 177. What was that output there? Variable is equal to 10. That is inside data, local variable. So output will be 10. Then it comes out to 182. What is 182? Again, it is away. This variable is away variable one. So it will print 100. So only 100, 10, and 100 is getting printed. So be careful. Now I'm not doing any operation. So this variable and this variable doesn't have any connectivity. This is local and this is global, altogether different. So that's why data are coming this way. Now look at this. Now I'm trying to do some other operation. Now look at this. What I did, I made that variable as a global. Initially it was 100. Now when the function gets called, again I'm telling, right? When function gets called, it will go there, and what I'm doing here, I'm making that global as a variable. I mean variable as a global one. So now when I run, look at the output. Output is 100, 10, and 10. Now it is not 100, 10, and 100 because First, before the function, it is outside variable. What is outside variable? 100 only. So 100 got printed. Okay. After that, what I'm doing, I'm trying to call my function. So it will go there. This is my function. But what I did, now I made this variable as global means what? Now there is no different data. There is no local and no global. Everything will be global. Everything will be a one variable. Now the variable becomes 10. So it is printing 10. So even after that function calling, the variable will be 10 only because I made that globally. Global means everything will be same data. So this way, variable is equal to 100. Variable is equal to 10. Now when I print variable, what is output? 10 because that's the latest global data. Same thing happens here. Okay. So writing this global will play a huge role. So you should be very careful in how to use, how to handle this kind of a scoping. Okay. So this scoping also, right? Book doesn't gives you a detailing. So that's why I thought of, giving you people a detailing with the simplest of example. You're going to see a lot of scoping, right? Scope without a global, scope with the global, local scope, enclosed to scope, so on. So make sure that you learn all this stuff without a fight. So that's how the scoping works. Now let us do let me teach you a small scenario on this global data only. Look at this. Definition, function, print, hello. Again, I'm calling a function. So now what happened? This is nested function. I'm calling line number 200. It will reach line number 195. It will print hello. As soon as it prints hello, what will happen? Again, the function will be called. It will go to the definition, hello will be printed. So the continuous loop will happen. So look at this. It goes for the infinite loop until it reaches its saturation. Look at this. It reaches saturation, it throws the error. Now, I'll try to guide you how to find the number of iteration. In the output itself, they would have shown you the number of iteration. Now, I'm going to take you people to manual finding of the number of iteration, the number of travel this function travels. For that, first you have to have some counters. Counter is equal to 0. Very obvious, correct? So now you're going to use this counter inside. So what you have to first do, you have to declare that as a global counter. You know it, right? Whenever initialization should always happen at the outside. And what is the next step? You want to use that inside a function. So you have to consider that as a global. Then what you have to do? You have to increment the counter each and every time. That's it. Counter. So when you run, now the output will be coming with the counter value. Look at it. This is how you should do the counter process in function. Declare initialize outside, make that as a global inside, and then you can use it. Then what happened? You can use it. For example, if I give a scenario like I want this loop to run for only 100 a number of times, what you have to do? You can use this method. There are a lot of methods you can do. If counter is equal to 101, what you can do simply return you put. So there is it returns. Or else you can put some while statement, whatever you wish you can use. So this is kind of a small logic what I want you people to keep in mind. Nothing much. Okay. This is again a matter of scope only, but you should know how to use the scope. Fine. And in function, we're going to see something at last like lambda expressions. Anonymous function. So there is something called lambda function or anonymous function. Okay, in Python. So what is this lambda function? I'll tell you one scenario. Look at this. Definition double variable return variable star variable. So output is equal to double of to print output. That's it. Straightforward function. The 2 will be passed on to line number 207. That will be squared. Square will be retrieved back at the output. I'm printing the output. This we see already. But the beauty of this is that the operation that I'm carrying here is very, very, very less. It's just one line of operation. And also sometimes there are certain functions where I may not be using too often. It might be 2-3 cases alone, I might be using that particular function. So in this kind of a scenario, if you know that you're going to use only in the lesser number of times, you can go for lambda based function definition. So lambda based function definition is available in Python just in case these two openings. What was that? One, the operation is very less. Number two, the frequency of usage is very less. On these two scenarios, you can go for the lambda based function. If you ask me why, this kind of a conventional function will occupy larger space and also the code will take some time to run. But lambda means it is without any template, right? So it will run the code quickly. So let me show you how to use it. Look at this. Double is equal to lambda variable colon. What is the output? Variable dot square. Output is equal to double of 2. Both are same. This is what we call it as lambda function. Here lambda means we call it as anonymous function. So that means it is not going to take any template memory. But here you can see that sir, both look so good, right? Almost one line of code difference. Of course, one line of code difference. But here there are a lot of iterations happening. Here there won't be. It is a straightforward execution. This is why we call it as lambda expression. When we should use when the function operation is very smaller, and also when the function usage is very less. When the frequency of usage is very less. That is where I should go for this kind of a function definition. Okay, I hope the people understood these points. Okay, right. We should start implementing these stuff. I have few things to say. Imagine this function double variable colon output is equal to variable of variable return output. Now I'm giving scenario. The output that is getting returned should be stored into another list. That's what my intention. So what I have to do? Output is equal to double of 2 and you will be printing output. So this is again another usual function that we see, the normal square. Exactly the opposite, the one which I did at the first, but this is with the return statement. Okay, now I want to store this output to another list. So what I have to do, I have to create my list first. First create empty list, and then here you have to do what? You have to do this one. My list dot append. My list dot append of output. So you need to print the list, correct? There is output got appended. This is straightforward. This is small one variable, so it got squared and it has been stored. Now now I have 4 lists. I mean, one list which contains 4 data, 2, 4, 6, 8. Now what I want this list to be passed on to my function so that I should get the output like 4, 16, 36, 64. Okay. So what I have to do, I have to pass here. So when I run, it will throw error. Why? Because at line number 136, I'm trying to pass the complete list as an argument. That is not possible. So you need to make sure that each and every data of the given list is passed on to the function. You cannot pass the entire list to do the operation. So what you'll be doing? You have to do the for loop. For x in. Okay, let me do it in separately. So what we'll be doing, we'll doing it separately. Okay, this way. So you have to do this for x in input list. That's it. Now you have to make sure that you keep this. That's it. Now what happened? You are using the for loop so that you will be passing each and every data separately. Look at this here. It should be x. That's it. Now when I run, you got the expected output. Square of those number into another list. But what happened? Since you know that you want to pass this list of data, you have to do the for loop so that you take data one after the other and do call on to the function. It will return back. You have to come back and append and then you see the output. So whenever you want to do this kind of operation, imagine the effort that you're making. It's very, very large, very huge, right? Now I'm going to use this set of function or I'm going to make this set of function into a simplest of execution. Look at this. First thing what I'm going to tell, I don't want the for loop. What I supposed to do? I don't want separate list to be declared as well. Not needed. So I have my input and my definition. What I'm going to do, look at this. Output is equal to map. Map is a function which is going to act as an inbuilt for loop. First, I have to map my function. I'm telling my map to do the mapping of the function with your input list. That's it. So when you print output, you won't get the output as expected. So output will return an object, memory object. So what you have to do? So output map is actually returning something. So you should keep some sort of a data type to retrieve or see the object. So look at this. So I'm using list of. So I'm trying to see the output in the form of list. There you see the same output. So map is basically to map the function with the iteratable sequential data. 2, 4, 6, 8 is a sequential data where I cannot pass directly to the function. Okay, so what I have to do, I have to keep getting that separately. So for that, I use the for loop like line number 247. I did lot of operation. Now the same operation with the quickest of code execution. No for looping. No need to mention the list separately. No need to use append operation. So lesser the operation, lesser the function that you use, the more the efficient the code is. Okay. So this is what this function. Similar to map, there are filter and reduce as a part of some functionality. Okay. This is very simple. Make sure that you work on that and keep practice each and every step, guys. So this is what the basic functions. Okay. The basic function definition and scoping everything. Okay, make sure that you always keep in mind and start doing one after the other. Okay.